So now can we note here that this sum can also actually be written as the sum of first the all the even powers of x plus the sum of all the odd powers of x with the coefficients. So I've just really done nothing here. I've just written this as the sum of the odd and the even powers. Okay, so now we have our formula for a to n. So we'll just put that in here. To n plus now 3 over, I'll just get the 3 out there. Oops. Okay, so 3 times the sum as n goes from 1 to 10, that's going to be real x to the 2n minus 1. Okay, so now let's just note one thing. So we all know that from the characteristic equation and stuff that this solution of this will be something like this, right? Oh, sorry, there's no E1 and E2, there's just one E, all is constant. So we know from the characteristic equation and the normal method that a solution should be something like this, something of this form involving powers of E. So now we have to remember one more thing here. This fact is very crucial, and this is really just the infinite series for E to the x. And this you can of course prove using Taylor series of e to the x. So now we have to actually convert this infinite sum into something involving e to the x. So how do we do that? Okay, so first of all, I'm going to separate out the 3 as 2 plus 1. So I'm just going to first write that it's going to be 2 times this sum x to the 2n minus 1 plus um, plus okay. Okay, so this is great. We are done till here. Now, we want something involving e to the x, right? So, let me just clear everything until now, I guess. Yeah, so we were done till here and I'll just clear everything until now. Okay, so what we had till now was that our function y is actually 2 times this sum as m goes from 0 to infinity of um again 2 times from 1 to infinity of x to the 2n minus 1 by 2n minus 1 factorial plus sum as n goes from 1 to infinity of plus fine, we had this sum. Okay, so this is our function. Now we have to convert this into terms of e to the x and e to the minus x. Okay, and now what I'm going to do here is I'm going to add this and subtract this part. You'll see why I'm doing this. So I am going to add and subtract this. That's wonderful. Now I'm going to group. So now I'm going to group these two as plus, and I'm going to take this here. So that gives us that is just 2 times the sum as n goes from 1 to infinity of plus sum as n goes from 0 to infinity of x to the 2n over 2n factorial Now that's our first term, and then I'm going to put a minus here. You'll see why I'm doing that. T of 2n factorial minus the sum as n goes from 1 to infinity of x to the 2n minus 1 by 2n minus 1 factorial. Okay, so now can we just realize that this is nothing but the sum of factorials, right? So if I put x is equal to 1, this is n x power 1 by 1 factorial plus x cubed by 3 factorial and so on. So this is the sum of odd factorials. Now again, if I put x is equal, n is equal to 0 here, is just 1 by 0 factorial, that is 1. X squared by 2 factorial, x power 4 by 4 factorial, and so on. So can we just notice that together this whole thing is actually going to include sum of odd powers of x by odd factorial plus sum of even powers of x by even factorial. So can I together write the sum like this, right? So that's just the sum as n goes from 0 to infinity of x power n by n factorial. So the total powers of x taken as x is a whole number, as for all whole numbers x, and divide them by n factorial, which is of course e to the x. So that's wonderful. So the first part of our function is 2 times e to the x. Now we move on to this part. This part may not look as inviting as first, but then it's very similar, trust me. So if we put n is equal to 0, we get 1 and x squared by 2 factorial plus x power 4 by 4 factorial and so on. Now note for the odd terms we have a minus, all right. So that's going to be minus x plus x cubed by 3 factorial plus x power 5 by 5 factorial and so on. Now if I open this, I get 1 minus x plus x squared by 2 factorial minus x cubed by 3 factorial plus x power 4 by 4 factorial minus x power 5 and so on. Now let's just remember that e to the x was defined as this. Now can we know that minus 1 per any odd number is minus 1 and minus 1 per any even number is plus 1, all right? So now over here we can just say that this thing is actually e to the minus x, right? Because all the odd powers have a minus here and all the even powers have a plus here. So this is just e to the minus x, and therefore our final function y is actually 2e to the x minus e to the minus x, and that is our final solution. So this was quite a long one. Of course, this can be solved very easily if you assume it's c1 e to the x plus c2 e to the minus x, the characteristic solution. But then really I just wanted to show that there are many different ways you can solve a problem, and that all of these just tell you different perspectives of how you can look upon a problem. That was another goal of this video, and just to cultivate among all of you viewers different methods and ideas to solve a problem. So yeah, I hope you liked today's video, and that's all for now. This is